Okay, so we are going to work on motion word problems again. I am going to actually solve the ones that are on the sheet that I gave you guys. And so I'm going to hold this up. I'm not going to do the first one since that was actually the lecture that I actually originally gave on the previous video. So we're going to look at number 2. An airplane flies at a constant rate east from Pittsburgh to Harrisburg in 1 hour 30 minutes and returns in 2 hours. If the wind speed is blowing at 16 miles per hour from the west, find the airspeed of the plane. Alright, so first of all, the wind is blowing from the west going east, so it's going from the west to the east. The first sentence says an airplane flies at a constant rate east, flying east, from west to east. Okay, so that's with the wind. Alright, so that's going with the wind. It takes them 1 hour and 30 minutes. So we need to turn that into number of hours. That's 1 hour, 1.5 hours, or 1.5 hours. He returns in 2 hours. If the wind speed is blowing at 16 miles per hour from the west, find the airspeed of the plane. Alright, so on your sheet, on your homework sheet, this is actually problem number 2. Okay? And so we are going to have our little box. We have rate times time equals distance. And we have, this is an airplane, we have a headwind, and we have a tailwind. Alright? So the tailwind is actually what we started with, because that's going in the same direction as the wind. So an airplane flies for 1.5 hours, 1.5 hours, and the wind speed is, okay, and it returns in 2 hours. So that's the return, oh wait a minute, excuse me, what am I doing? I did that backwards, sorry. The tailwind was 1.5 hours. The headwind is going to take longer, so it's going to be, that was 2 hours. And it says the wind speed is blowing at 16 miles per hour. You can, I'm assuming you've got your sheet with you, you can look at your sheet to see what I'm reading. But the wind speed is blowing at 16 miles per hour. Remember, this is going to be split up between the speed of the vehicle on the left and the speed of the wind on the right. If it was a boat problem, the speed of the current on the right. We right now know that the speed of the wind is 16. So I'm going to write that, 16 for both of those. Okay? It says, if the wind speed is blowing at 60 miles per hour from the west, going west to east, find the airspeed of the plane. In other words, find this. So I'm going to just erase this little dotted line for a second, because I don't want that to confuse you. So this is what they asked us to find. The tailwind is pushing you faster. The headwind is subtracting, making you go slower. So now I just have to multiply to find my last column. I just do rate times time, which means I'll be using the distributive property, 2 times x minus 2 times 16. So that's 2x minus 32, and this is 1.5x plus, I think that is 24, I believe. 24. This now, we've just figured out, this is D1, this is D2. The formula you're going to use is D1 is equal to D2 because the distance from A to B and the distance from B to A is the same. So we're just going to set these two equal to each other. This equals this. So you set it equal to each other, 2x minus 32 is equal to 1.5x plus 24, and you'll eventually come, where did I do with my answer sheet? Sorry. You'll eventually come up with x is equal to 112 miles per hour. So the airspeed, so you'd find out that x is equal to 112, so you'd say the airspeed is 112 miles per hour, and you put it in a box. So that solves the first one. Now I lost, where is my, sorry, hang on one second, I gotta find my, oh well, we'll I'll just use a Kleenex. Okay, so that's the first one. All right, I'm just going to go through these fairly quickly because you can pause these and see how I set them up. But I just want you to see how I'm setting these up. That red marker doesn't seem to work too well, so I'm going to change to a green. Hopefully this works better. All right, now we're going to go to problem number 3. Problem number 3, hope I can hold this up so you can actually see it. I think you have it. A plane flies from New England to North Oak in 3 hours and returns in 4 hours. So obviously if it takes him 3 hours to get there, he has a tailwind, and he has a headwind when it takes him 4 hours. If the speed of the wind is 25 miles per hour and it is blowing in the direction of North Oak from New Eagle, find the airspeed of the plane. So I'm trying to find the speed of the plane. Okay? So again, so this is number 3. So I'm going to draw my box. I think once you see a bunch of these done, it's going to be pretty straightforward and pretty easy. So again, we have rate times time equals distance. We have a headwind and we have a tailwind. Okay, you just have to make sure you put them in the right order, whichever one. It doesn't matter which one you put here, you just have to put the right information in these boxes. So they're going 3 hours. Okay, that was a tailwind, 3 hours and 4 hours. I know that this has to be shorter with a tailwind, so I know that. I also know that the wind speed is 25 miles per hour. There's my 25. My wind speed always goes here. Alright, with the tailwind, I know I'm going to be adding the 25. With a headwind, I know I'm going to be subtracting 25. They're asking me to find the airspeed of the plane. They're asking me to find this. Well, that's x. So, now I just rate times time equals distance. This times this equals this. This times this equals this. So 4 times x is 4x. 4 times negative 25 is negative 100. 3 times x is 3x. 3 times 25 is 75. That's my D1. That's my D2, my distance 1 and distance 2. Remember, D1 is equal to D2 because I go from A to B and then B to A. So I just have this equal to this. So I do 4x minus 100 is equal to 3x plus 75. So for this one, your final answer would be, what I got at least, the airspeed of the plane is 175 miles per hour. You'd solve for x, and it would say 175. So airspeed is 175 miles per hour. Put it in a box, and you're done. Alright, so that's number 3. I hope this is helpful. It's really important you guys get to know these things because this is definitely the kind of question that entrance exams going into high school will want you to take, want you to answer. So if you don't know these kind, it's not going to be so good. You'll end up having to repeat Algebra 1, which is not horrible, but it just is the way it is. Okay, now we're going to move on to number 4. Number 4. Okay. So number 4 says, a little hard to do this. Okay. If a boat travels upstream from point A to point B in 2 hours, 30 minutes, and returns downstream from point B to point A in 2 hours, find 2 hours and 30 minutes and 2 hours. Okay. Find the speed of the boat on its speedometer if the current is 3 miles per hour. So we know the current. They're asking us to find the speed of the boat in relation to the water. Okay? We know we're going upstream and downstream. Okay? So obviously downstream it's going to take 2 hours. Upstream it takes 2 hours and 30 minutes. Okay. So we're gonna, this is number 4. We're gonna draw it out again, our little box. This is why you need these boxes. I know before they didn't seem that important, but now they get more complicated. And so we know we've got a downstream, and we know we have an upstream. We know the downstream is going to be a smaller number here. It's got to be. So immediately I see my downstream was 2 hours. My upstream is 2 hours and 30 minutes, or 2.5 hours. All right, this is my rate, my time, my distance. Right? So, and it says, this is number 4, right? Okay. Find the speed of the boat if the current is 3 miles. My current is here. My boat speed is here. So I do 3, 3. When I go downstream, I'm adding. When I go upstream, I'm subtracting the current, right? The current is slowing me down. I'm supposed to find the speed of the vehicle, speed of the boat. That's x. I have now filled in these 2 columns. This one is just merely found by multiplying this times this. So that's 2x plus 6, 2.5x minus 7.5, I believe. Just be sure so I don't have to get my calculator. 7.5. Okay, so now that's my D1, that's my D2, this equals this. So if you set this 2x plus 6 equals 2.5x minus 7.5, then my final answer would be the speed of the boat is 27 miles per hour. Boat speed equals 27 miles per hour. Again, I got that by 2x plus 6 equals 2.5x minus 7.5, and I solve for x, and that's what I'll get. All right. Okay, so now that is that one. We're going to move on to number 5. Okay. Number 5. Sorry. This is a little tricky. Okay, if a plane flies from Mount Pleasant to Waltersville in 5 hours with a headwind of 25 miles per hour, returns in 4 hours with a tailwind of 20 miles per hour, find the airspeed of the plane. So they're asking us, they gave us the headwind and the tailwind. So the tailwind is 20 miles per hour, the headwind is 25 miles per hour. This is actually different than some of the others because the actual wind has, the speed of the wind itself has changed. It was 25 going into the wind, and then as they turned around, suddenly the wind stopped blowing as hard, and it's going only 20 miles per hour. We're supposed to find the speed of the plane, the left side of the rate column. All right, so this is number 5. So number 5, so we got to draw our box again. I hope you're starting to see why these boxes are useful. So this is a plane. We've got a headwind and a tailwind. Head, tail. Just have to make sure you put the right thing in the right place. Rate times time equals distance. All right. So with a headwind of 25 miles per hour, it takes 5 hours with a headwind. 25 miles per hour. And that's a headwind that's going to be subtracted from the speed of the boat, right? Or the speed of the plane, right? And then I return in 4 hours going with a tailwind of 20 miles per hour. So I'm going to add 20 to the speed of the boat. And they're asking me to find the speed of the boat. Find this. So that's just x, right? So again, this is gotten by multiplying this times this. So we have 5x minus 125. And then we have 4x plus 100. Again, this is D1, this is D2. From A to B and B to A, they're the same, so D1 equals D2. So 5x minus 125 is equal to 4x plus 100. That's what I'd write here, and I'd solve for x. And when I do that, my answer would be the airspeed of the plane. Airspeed of plane is 225 miles per hour. Put it in a box and I'm done. Okay. So that's number 5. Now we're going to move on to number 6. Just erase this. I'm hoping you're getting the idea now. They're really not all that hard to do. Okay, number 6. A boat's speed on its speedometer reads 18 miles per hour going downstream. So that speedometer is only telling us how fast the boat is going in the water. It's not telling us that the water is also moving. And so that because the water is moving, the boat's actually going faster in relation to the ground, the land, the banks of the river. It reaches its destination in 1 hour 15 minutes, and this was going downstream. And again, 1 hour 15 minutes, you have to write that in terms of hours. So 15 minutes is 1/4 of an hour, or 0.25 of an hour. So 1 hour and 15 minutes is 1.25 hours. The return trip takes 1 hour 45 minutes. Okay, that's 1.75 hours, because 45 minutes is 3/4, or 7.75 of an hour, going 18 miles per hour on the speedometer. Find the speed of the current. So we're looking for the right side of the rate column now. Okay, so this is number 6. Number 6. Again, my chart. I wouldn't do these without a chart, personally. Wouldn't even consider it. Rate times time equals distance. Okay, we are talking about a boat, and we're going downstream and upstream, right? So down and up. Okay, downstream, speedometer says 18. That's the speed of the boat. Right, going downstream. Actually, going upstream, it also says it's 18 miles per hour, so I'll put that there too. Going downstream, it reaches destination in 1 hour and 15 minutes. That's 1.25 minutes. All right, and going upstream, it's 1 hour 45 minutes, 1.75 hours. Okay, find the speed of the current. This is the current here. Downstream and upstream. Downstream, I know that I'm going to be adding the speed of the current, right? The current is x, and here going upstream, it's pushing me down. It's pushing me down a little, slowing me up. All right, so that's what I've got. Now, to find this column, this times this times this. So 18 times 1.25. This is number 6. I'll just use my notes here. I've got 22.5 plus 1.25x. And I guess I needed more space. Give myself a little more space. And then we have 30. This times 18 is 31.5 minus 1.75x. That's my D1. That's my D2. You should know what to do now. This equals this, right? And so if I do that and solve for x, I'll find that the current, remember, that's what I'm looking for, the current speed is 3 miles per hour. Put it in a box, I'm done. So that's 6. 2 more. 2 more. Alright, so 7. I know I'm going to need my box. I'm going to just draw it right now. 7 is a little trickier. Rate times time equals distance, because they asked a different kind of a question. Okay. 7, 7, 7. Alright. Okay, so verse 7. Here we go. Alright. Whoop. There we go. A plane flies in a headwind of 22 miles per hour from East Grove to Uniontown in 6 hours and returns in 4 hours with a tailwind of 22 miles per hour. So the headwind and tailwind are the same. Find the distance between the airports. Oh, that's interesting. Find the distance between the airports. Well, let's fill everything in and see what we don't have. And maybe that'll give us a good idea of what we need. It says a plane flies with a headwind. So we have a headwind, and we have a tailwind, right? With a headwind, 22 miles per hour. That's the speed of the wind. And also coming with the tailwind, also was a 22 miles per hour speed. With the tailwind, you're adding it. With the headwind, you're subtracting it. All right. We don't know what the speed of the boat is. Speed of the plane. So I'm going to put that as x. Put that as x. My time. Let's see here. The headwind, it takes 6 hours, and tailwind, it takes 4 hours. That makes sense. Tailwind makes me go faster, so I do it in less time. All right. So now. But they asked me to find the distance between the airports. They're asking me to find what is the distance between the airports. Well, first of all, let's try multiplying this out. Let's get this filled out. So 6x minus what is this? 7 minus 132. 6x minus 132, and then the other one 4x plus 88. 4x plus 88. Alright. So the problem is there's an unknown. I need to know the distance, but I don't know what it is. But there is a way to find out. I set d1 equal to d2. And this one I'm going to do. 6x minus 132 equals 4x plus 88. Right? I want to get my x's together. I'm going to subtract 4x from both sides. And at the same time, I want to get this over there, so I'm going to add 132, add 132. And when I do that, I've got 2x is equal to 220, I believe. Divide by 2, divide by 2. X is equal to 110. Okay? So that's the speed of the boat. But that's not what they asked for. They said find the distance between the airports. But now that I know that x is equal to 110, I can choose either one of these because the distances are exactly the same. Hang on. Where's my phone? Sorry. Okay, the distances are exactly the same, right? That is equal to that. So it doesn't matter which one I choose. I'm going to choose this one. It looks easier. So I'm going to say, so the distance, to find the distance, I'm going to say 4x plus 88, and I'm going to put 110 in for x. So 4 times 110 plus 88. That's 440 plus 88. That equals, I think it's 528. 528. All right. So the distance between airports, I'm not going to write it all. The distance is 528 miles. Put it in a box and I'm done. So that's 7. Makes sense? You've always got to read the question because they asked something that required you to do what you've been doing, but then suddenly you also had to go one step further and find the distance or tell them the distance. So that was a more tricky one. Perfect. A little entertainment. Okay, last one. This is it. And some of you guys may feel like you already know all this now and you don't need all these, but that's okay. For those of you who do, I'm doing them all. Sorry. Okay. If a small plane flies from San Diego to Boston in 8 hours with a headwind of 10 miles per hour, it's a headwind, 10 miles per hour, returns in 7 hours with a tailwind of 10 miles per hour, find the airspeed of the plane. What's that note? Rate will be the speed of the plane, which is x plus or minus the speed of the wind. Okay, well you guys know that by now, right? Okay, so 8. So this one actually is quite easy, right? That number 7 was the hard one. So here's our little box again. We have rate times time equals distance. I almost don't think I even need to do this one, but I will anyway. So we've got a headwind and a tailwind. Head, tailwind, it's a plane, with a headwind of 10 miles per hour. That's the speed of the headwind. 10, 10. Headwind pushes you slow, makes you go slower, so it's going to be subtract. Tailwind makes you go faster, so it's going to be plus. We don't know the speed of the plane. That's what they're asking us to find. And then we also know that with the headwind, it took 8 hours, and the tailwind, it took 7 hours. That makes sense. Tailwind would be faster, so less time. Okay, so we just multiply this times this. 8x minus 80, 7x plus 70. Right? That's my d1, that's my d2. d1 is equal to d2. Right? So it's just going to be, I solve it, and my final answer, drum roll, is airspeed of the plane is 150 miles per hour. Airspeed of plane is 150 miles per hour. Put your box around it and you are officially done. So that's it. That's how they work. I hope that's useful. We're not going to spend a lot more time on it, but these will definitely be on the next test. So make sure you know how to do them. If you don't, and you're still confused after this lecture, please get back to me. Okay, that's it. Thanks. Bye.